Welcome to ArcGIS Runtime, building cross-platform apps. It's a jam-packed session. We've got a lot of devices on the table up here. We're barely making them fit. There's a lot of heat being generated up here too. So we're going to try and work through these as quick as we can. We've got a lot of stuff to show off this 1 hour session. My name is Rex Hansen. I'm a product manager for ArcGIS Runtime. I'll be your host for the next hour to walk through the cross-platform development options with ArcGIS Runtime. I'm joined by Mark Baird, who's going to show us Java, Michael Timms, who will show us Qt, and Morten Nielsen, who's going to show us .Net. So we're going to walk through these different sections. But before we get there, I want to give us a little context on what we're going to be looking at. So obviously we're going to take a look at cross-platform. What does it mean in the context of runtime, right? So we need to provide a context for it. And then we're going to dive into some specific details, comparisons, contrasts between the different technical capabilities and developer experiences that we have within runtime. So first, just to set the stage, a lot of times when you talk about cross-platform development, you talk about web versus native, right? So we just wanted to lay it out in a nice set of text here and just talk about what do we mean by web and native. So if we're talking about native strategies, we're talking about choosing the best device, the best experience that you can find out of the box for creating connected and offline workflows, and generally require native development skills, being able to take advantage of onboard sensors and resources and capabilities of a device. And for that, we have the ArcGIS Runtime SDKs. And that's what we're going to be talking about today. We're going to focus on that. But there's also web. So the web also provides, through HTML, JavaScript, CSS, and other web technologies, via web server, generally a great connected workflow for use in a browser, whether it's in a desktop or it's in an app, or whether it's on a smaller or mobile device, that's best for those connected workflows where you don't necessarily know what type of devices that your users are going to have. You need to be able to support a lot of different device types depending upon what you expect your user community to leverage. For that, we have the ArcGIS API for JavaScript. Right? And so that's a web technology that allows for cross-platform development. So a lot of the concepts that we find within native will apply to the web as well. But because we're talking about runtime, we're going to talk about native. So cross-platform, native application considerations. Some of the benefits. Obviously, one of the major benefits is you're able to share code in your developer experience, but also target multiple platforms, right? Multiple operating systems with shared code. Depending upon which technology you choose, you might be able to share more or less code. So depending upon which option you work with or the complexity of your application, you can share quite a bit of your development experience and your time and effort put into building your application. What this does do is it generally enforces good design patterns because you do have to be able to consolidate your business logic in a way that can be reusable, right? So that's a benefit to the development workflows that you'll be employing in building out a solution that needs to target multiple platforms. And of course, one of the main benefits here is that while you do get to share code, you also get to target more operating systems, more devices. So leveraging your time and your money most effectively to be able to build a solution that can target a larger market, right? That's a critical need, and that's one of the reasons for targeting a cross-platform solution. Now, there are a couple of challenges. Obviously, with different device types and different operating systems, the user experience may differ, right? So you may have to spend some time building out different UIs, different immersive experiences that your user community expects because they want the application to look and feel natural on the device that they're using it. It might take a little time, so sometimes that's a challenge. Sometimes those involve some differences in your application coding that you'll have to account for. Also, because you're targeting multiple platforms, you might have to work with or work against different idiosyncrasies in those platforms, bugs, features, capabilities, levels of access. You might also have to target different device styles and types that may or may not have additional functionality, so you have to be able to accommodate for that, right? So as your reach, as far as targeting devices is concerned, as it expands, the complexity expands, right? And so there's a cost associated with that. It obviously, at that stage, involves more testing, right? So you're gonna have to test the devices and the different platforms that you target, and that actually could include or increase your development cost. It could require more time and effort to actually build out a solution that targets more platforms. Now, granted, that development cost might also involve licensing developer experience, that you didn't have to license before. You know, if you switch from, let's say, a Visual Studio Community to using Qt Creator, maybe it costs more based upon the developer licensing models that are associated with the technology that you're using, right? So something to consider there too. So the critical question, which one's right for me? Well, there's a couple different factors here. One is, what do your users expect? What type of experience do they expect, and what platforms or what devices do they intend to use, and how do they intend to use them? Do they need to go offline, right? Do they need a partially disconnected experience? Do they need an immersive experience that's responsive? What are the expectations of your users, right? What do they need you to target? And how is that application going to be delivered? Can they expect for that application to be delivered in a browser? Do they need that application to be delivered via store or via some sort of a side loading or enterprise mechanism? Right? You need to figure out which option you have available and which is at your disposal. That will often dictate which, from a native app perspective, which developer technology you can choose. The other thing to consider here is the development skills of your team. So what skills do you have? Are you a .NET shop? Do you have a lot of developers on hand that know how to work with C#? But you need to be able to target iOS or Android. Well, great. .NET on the Xamarin platform can target iOS and Android. You need to target Linux or Mac, and you're looking for a cross-platform solution. Well, .NET's not going to serve that purpose, right? So that might be a Qt solution, right? It might be a Java solution. Now, the key factor there is you need to evaluate the skill level of your team and how much time or effort it's going to take to retool that team if you need to. Right? Ideally, you don't have to. You're able to leverage the existing knowledge that you have. Right? So it's critical to be able to leverage that existing knowledge, get up and running, rapid application development as soon as possible. With that in mind, you might have to be prepared to learn something new. Right? So if you need to be able to target a platform that maybe the technology that you're most familiar with doesn't target, you might have to learn something different. Right? If that's a critical need for your user community. Right? So something to keep in mind. And we've got a couple of different players in this market. We've got Oracle with Java, we've got Qt, the Qt company, and their Qt platform, and we have Microsoft with the .NET platform. Right? We're going to take a look at these players today. We've got other players in that market too, but these are the ones that we're going to focus on because these are the solutions that are most pervasive and solutions that we provide a solution for. Actually, we provide a development experience for within the runtime. Just to highlight how this is leveraged within ArcGIS Runtime is first, just a broad overview of Runtime. We built out a lot of our functionality, a vast majority of our functionality on a shared runtime core, which is built in C++, targets multiple platforms, such as Android, Linux, iOS, Mac, Windows, and UWP, target multiple architectures and different rendering pipes that are associated for these different platforms and different solutions. So with that shared runtime core, we built out a set of vertical SDKs, right, for developer experiences that are common or most functional for the developer community as we see it today for native app development. Now, with regard to the boxes at the top, which are products that we make available, there are really three that we target right now and promote as cross-platform solutions. Java for Windows, Linux, and Mac. Qt and QML for every platform that we have listed up here, Android, Linux, iOS, Mac OS, Windows, and UWP. Well, sorry, UWP not quite yet, but it will be there. And .NET Xamarin, which will target iOS, Android, Windows, WPF, or UWP. Right, so these are our three promoted technologies, developer experiences, development environments that we provide a Runtime SDK for that you can use to target cross-platform solutions. And what I'd like to do is dive into this a little bit further, and so with that, I'm going to introduce Mark Baird, and he's going to take us through the Java experience with respect to cross-platform. Mark?
Okay, can we see the slides? That's good. Right, so looking at this from a Java point of view. So Java, some people love it, some people hate it. Morten's a really big fan, incidentally. Java's everywhere. We've certainly got it installed on my two laptops here. It's questionable whether it's there. But you may, or it is, well done, that's good to see. You might find it on your telephone, on your watch. It might be in the menu system of your television, in the entertainment system of your car. It's all over the place. 3 billion devices, if you believe the splash screen. But that makes it very good for an environment where you can write applications for multiple platforms. Now, the Runtime release, version 100, is really to support Windows, Mac, and Linux in terms of the operating systems that we support. So this is really aimed at the desktop platform. So we're all about writing JavaFX applications. Not Swing anymore, we've moved on for that, so it's just JavaFX. Now, the architecture is fairly familiar in that your applications run inside a JVM. That's interesting. And they sit on top of the ArcGIS Runtime architecture, which Rex was showing there. So as a developer, you will choose your development environment of choice. So common ones, there are lots out there, but Eclipse, IntelliJ, and NetBeans seem to be fairly commonly used. And you'll use this to develop and hopefully perform lots of testing before you actually go ahead and compile an application that's built up in a runnable jar file. And you'll deploy this into one of your chosen platforms, so Windows, Linux, and Mac, and it runs inside the Java runtime environment. Now, because if we're not writing pure Java applications here, they're built up on the C++ core that we compile up and give to you as binaries. So if you want to be able to run the application in a Windows environment, you need to make sure that you've got the appropriate DLL file for the runtime. And then you'd need the SO file for Linux or the dylib for Mac. And actually, if you make a deployment that includes all of the different binaries, you'll write an application that you can deploy and run on any application, on any desktop machine you choose to run it on. So what are the considerations for writing cross-platforms in Java? Generally I would say it does just work. JavaFX is pretty consistent in its behavior on all platforms. There are differences, but these differences are a good thing. So if you look at the screenshots of the two applications I've got down here, you can probably tell which one was run on a Mac and which one was run on a Windows machine. So good differences. I think the only pitfall you need to be a little bit careful of is when you're working with file systems. If I was to write myself an application on a Windows machine and I was to hard code the location of a file that I wanted to make use of as C:\\, and then I deployed that onto a Mac or a Linux machine, it won't come to any surprise to you that it won't work. So you need to sort of bear this in mind. I would say probably the easiest way of actually getting around this problem is to make sure that any files that you're working with are put into a relative location to the point where you're running your application from. And also make sure you use // because they're accepted by Windows machines as well as backslashes. If you can't use relative file locations, then I would suggest you consider using something like environment variables that you can set up on any system in order to be able to help you locate your files. Okay, so I'm going to switch over now to Eclipse on a Windows machine and show you an application that I'm going to deploy cross-platform. So I'm going to fire the application up to start with. It's a very simple application. I'm looking at a 3D scene view, and I'm representing the location of a single point here, which I'm drawing using this collider symbol. So it's sort of an aircraft symbol that we've drawn. Now that aircraft model has come from a file which is located on the hard disk of my machine. So if I just shut the application down, you'll see here that I'm using a relative file location. I'm using my / samples data Bristol collider Bristol DAE as the route to my file. So when I compile this up, as long as I make sure that that path is present on the deployment machine, then the application should work on a different machine. So I'm going to switch over now to my Mac, which is that one. Okay, that's working. So I've got here the application jar file that I compiled on my Windows machine. And you'll notice here in a relative path location, I've got my samples data. This is the location of my collider model. And also if I open up the JNI libs here, you'll see that I've got directories here which contain the binaries for the different platforms that I could run this application on. So this app would work on any platform, Windows 32-bit, Windows 64-bit, Linux or Mac. So if I fire this application up, hopefully we should see exactly the same as we were experiencing on the Windows machine. Okay, so just go back to number 3, just to conclude. I'll go back to my slides. Okay, so just to summarize here, working with Java, so it's a development platform for runtime applications. I would say the advantages of working with Java are that the IDE and the JRE that you need to deploy on all of your machines are free, so there's no cost to deploy it there. There is a cost to deploy runtime, depending on what licensing level you use, but that's a different story, and that's consistent across all of the SDKs. The deployments can be identical across all platforms, so you can make a deployment that will work on Windows, Linux, or Mac, and it's exactly the same. It'll work regardless of which machine you plug it into. And the JavaFX applications do style themselves to work on the platform they're working with. So, I'm looking at the title bar here of a couple of different applications, and you can tell exactly where they came from, those screenshots. The disadvantages you may come across are that, well, the application won't work if the JRE isn't present. But there are sort of approaches to dealing with that. So if you're working in a big enterprise, there are enterprise deployments of Java which are very easy to set up. So they can be centrally deployed onto all of your client machines. Or if that's not an option, the other alternative, if you haven't got the JRE present on the machine, is you can actually make deployments which are self-contained. So they actually contain the Java runtime environment alongside the runnable jar. It just makes the deployment a little bit bigger. So the major difference between the Java platform and what you're going to look at from my colleagues' demos here is that we don't support mobile applications. So Java, as I say, it is just for desktop. Rex.
Good deal. Great. Ooh, that was weird. Great. Thanks, Mark. Okay, so we're going to spend a little bit of time transitioning here. Quick question for the audience. We've had time to settle in, about 15, 20 minutes in maybe. Anyone here currently using Java, the Runtime SDK for Java? 1, 2, 3, 4, 5. Okay, good stuff. Anybody want to use Java that's not right now? Okay, good stuff. Interesting.
Morten.
Interesting. Okay. Let's try another one. Anyone using the Runtime SDK for Qt right now? Qt. Okay, we got a few in the back. Good stuff. Anyone want to learn how to use the Runtime SDK for Qt? Okay, here we go. It's good smattering. Good stuff. Okay, now we're going to go to the granddaddy, Runtime SDK for .Net. I expect a lot of hands on this one. Right? Oh, look at that. That's nice. Anybody who doesn't know .Net but wants to learn .Net just so they can take advantage of Xamarin. So you guys are already weathered. Oh, okay. All right. Mostly weathered veterans, actually, right? This is great. Already familiar with .NET tooling and experiences. That's great. Okay, good. Good stuff. How's it going, Mike? All right, great. So now we're going to hand it off to Michael Timms. He's going to take us through QML.
All right. Thanks, Rex. So I'm Michael Timms. I'm going to be talking about building cross-platform maps for Qt, QML, and just some things that you need to be aware of if you decide to use QML as your cross-platform framework. A little bit about the Qt company. The Qt company designs Qt. They built Qt for a long time now. Really, they probably wouldn't be in business if it wasn't for cross-platform. They've been building cross-platform for many years, a huge open source community, and there's lots of good things about the Qt company when it comes to building cross-platform apps. Platform support as far as the ArcGIS Runtime SDK is concerned. Currently with our latest 100.0 release, we support Windows, Linux, macOS, Android, iOS. Probably coming in at a future release, we'll bring in the Windows Universal support. That's mainly being driven by App Studio. How many of you have heard of App Studio or anybody using App Studio? So App Studio is built on top of the QML API that's produced by this ArcGIS Runtime SDK for Qt, and they have a requirement to bring in Windows Universal support. So we're bringing that in as well at a future release as soon as App Studio actually gets up on our current release. What we deliver is one SDK This SDK has two APIs packaged in it. We have a C++ API for C++ developers. C++ API at our 100.0 release is available on all platforms. Prior releases in our 10.x days, we only supported desktop, but that's available on mobile as well. You can use widgets for UI. That's sort of the traditional UI language for C++ developers. Or you can actually build your UI in Qt Quick, which is the QML framework for UI, and write your business logic in C++. And you can do that for mobile devices as well. Modern C++ language. This is all really good stuff about the C++ API. It's very fast. We get a direct binding onto our runtime core that Rex talked a little bit about. As far as the QML API, this is where you would build your UI in QML, or they call it the Qt Quick framework. And this is a declarative type language, kind of looks like JSON, you know, CSS in a way. Web developers have found it to be pretty easy to get used to the syntax. And what you would do with the QML API is you'd write your business logic in JavaScript, because the QML engine runs on top of a JavaScript engine. And that's where we get a lot of attraction to our web developers that are looking to come over from the web and actually build native apps. So that's one thing to keep in mind about the QML API. Obviously, this is a native SDK. You have to make sure you're getting your compiler and your SDK dependencies set up. So iOS, you're going to definitely need Xcode compiler, Windows Studio, Visual Studio compiler. Linux, we're with the GCC compiler. Android, you've got to get the NDK and the SDK in order to actually get the bits and plug that in to the Qt framework. Once you get this all set up, you're good to go on the different platforms. Now you can use the same code across all these different platforms. The IDE of choice is Qt Creator. You can integrate like Visual Studio with Qt, but if you really want to go cross-platform, Qt Creator is the one that we want to promote and we want you to use, because it gives you a similar experience across all of the different desktop platforms. You can actually design, develop, test all from this one IDE, and the workflow is the same on that IDE on all the platforms. We deliver an extras library specifically for Qt Quick and QML UI. It has certain things in it that are missing from the Qt framework, or that you can actually really take advantage of from the Qt framework. You probably have seen some of this, some of you App Studio folks, where you want to scale your UI, and we give you a scale factor, and what that does converts pixels into device independent pixels, so you can scale your UI for your high DPI devices. Qt's got support for high DPI at their 5.6 release, but it doesn't really work too well on Windows, because it sort of rounds the scaling to the nearest integer, and that doesn't work too well on fractional UI. High domain APIs, file I/O. That's one of the ones that we have to actually expose to QML because it's not available. You have to get into C++ in order to get that. So there's some of these APIs that we bring up and expose. And also App Studio's app framework has a many more of these. So a lot of folks come in through App Studio to hook on to the QML API, and they give you many more different ways of getting at some of these APIs. Some of the things worth noting that's coming in the Qt framework: push notifications. I'm asked about this every year, all the time. It's not something that's out of the box in the Qt framework. So something to keep in mind: if you need push notifications, you might have to implement it on your own or choose a different solution. We're definitely banging on the Qt company to get this pushed out. You can find some solutions on the web for cost, but yeah, just something to note. Qt speech, text to speech, that's in tech preview at the latest Qt release. Background suspended location updates works pretty well on Android right now with spinning up an activity to be able to get your updates while you're suspended. But iOS, there's still a bug in the Qt framework that we're working with the Qt company. If you use App Studio, they've got that fixed in the actual cloud make, so you'd actually get the fix so you can have backgrounded suspended location updates on iOS. Access to photo gallery on Android is not available. You can get access to your photo gallery. Say you want to attach a photo in your application. There's actually a GitHub repository that someone actually developed that for Android, but it's not available out of the box in QML. So those are some things we know that are going to be coming soon in the framework I wanted to highlight. Qt Quick Controls. So Qt Quick Controls are these basically the UI controls, and they have a 1.x version and a 2.x version now. The 1.x version is really built to try to render the native controls of the device. So here you kind of see some screenshots here of Mac OS and Android. They sort of look like the actual device UI controls that are available on those platforms. And with Qt Quick Controls 2, they've actually kind of gone a different direction where they have the ability to spin up material design or universal style. And that way you can actually get either a material look or a universal look no matter what platform you're running on. So it is kind of, it's interesting because you can have the same UI across all your devices, but it's interesting sometimes to see a material style maybe running on your iPad, which I'll show you in a second. So here we go. I'm actually running an application side by side. The one on the left-hand side is actually using the material design. You can kind of see it has like an Android material kind of feel where you can set themes and you can set colors, and you can actually choose something here. And we have a little drawer that's popped up. It's got the dark theme background to it. And we have this charting. So QML has this nice charts, the UI that's built into the framework that makes it really easy to actually plug in your data to these charts. And those are available out of the box. Notice this drawer, I can kind of go up and down. That's something that's available out of the box at Qt Quick Controls 2 as well. Whereas the right-hand side, notice I clicked the combo box and it sort of brought me up the iOS control, and it's a little funky because it's meant to be full screen and my app is running kind of split screen here. But this gives you the ability to actually have the native look of the control, but that's with Qt Quick Controls 1. Now this drawer here, I've actually had to code this up myself. It's something that if you wanted to use Qt Quick Controls 1, you'd have to code that up yourself because it's just not available in Qt Quick Controls 1. So that's what I've done. I made a little button that kind of zoomed it in and out, whereas with the other drawer, with the other drawer I can actually work with it, and I didn't have to do any coding to do that. So something to keep in mind, Qt SDK licensing, won't go too much into this, but Qt is licensed under a dual license model, either commercial or open source. Commercial gives you full use to the software, do whatever you want with the software. Open source, you can get these for all the different Qt versions. I do note the license change from LGPL v2.1 to GPL and LGPL v3 at the 5.7 release. So just different license models to keep in mind when you're working with Qt. More information than I can probably explain is available on Qt.io, which is the Qt company's website if you want to check out their license models and what's available. So just to, actually I wanted to show you real quickly if we can go over to 4. Something I kind of missed here. So this is actually the same app that I had running on the iPad, running on this Android tablet. Same code, same app. You'll notice it's got the same kind of material look and design. The drawer pops up. It's exactly the same, looks exactly the same. And this can be kind of neat for you folks that maybe want to write one manual for your app for your users. where they don't have to maybe learn how to use it on Android, learn how to use it on iOS. So that's one way, and then we have the Qt Quick Controls one, where we have a little drop-down box here on Android. So just wanted to show that real fast. So back to 3. And then sort of in summary to finish off here, I got some pros and cons that are worth noting about the Qt framework. The pros are usually kind of obvious. You got the same modules, the Qt framework's cross-compiled, built on all the different platforms. You get the same modules, same functionality, with the same code and all the same workflows. And this is all really, really great if you just want to pump an app out real fast and get it running on multiple platforms. You get access to sensors, like Rex had said, and you got this open source community in which you can actually log bugs, get the open source community to fix these bugs, or participate in the open source community yourselves. The actual framework source code itself is available to you to take that code and tweak that code and maybe contribute back as well. Some things to watch out for, some of the cons: incomplete initial APIs from Qt. I kind of spoke a little bit about like file I/O. There might be some things that are not exposed to QML. And then we have wrappers around the iPhone and Android SDKs. Qt builds their own API on top of the actual Android SDK, iPhone, iOS SDKs. So if there's anything specific to the platform, say like an AirDrop API, you may not get it with Qt because their purpose is to build this cross-platform API where the devices share the same functionality. And because Android doesn't have AirDrop, well, you may not get that API. So there's some things like that to look out for, that if you have specific things about the platform, they may not have that API exposed. So that's worth investigating. Look and feel the native platform. There are some native controls that don't exactly look the best, like the message. There's a message box that pops up on iOS. It doesn't really look like the native iOS message box. So that's something to keep in mind, is you may want to kind of cycle through those UI controls and take a look if you want to get that native look and feel of the platform. The Qt framework is also, it's built in C++. It's an extra framework built on top for UI, so you can increase your app size if you use the Qt framework, just because it carries along that extra runtime, those runtime libraries that you may need. So that's it for Qt. We'll go over to Morten now for .NET and Xamarin.
Thanks, Michael. All right, there's a lot of people here that probably already knows what Xamarin is, judging from all the hands, but I'll still cover it for the ones that are not. But first, .NET and cross-platform, isn't that a Windows thing, right? And when we talk about the .NET SDK, and you might not see the whole lot of Xamarin sessions here because they're really the .NET sessions. And that's really because we have a bunch of things inside the .NET SDK that supports multiple things. We support WPF like we've always done. New for the 100 release, we support the universal apps, which is very similar to WPF, but it's this new Windows platform that'll run anywhere. Like it'll run on this phone. It's a rare sighting of a Windows 10 mobile phone. I have the HoloLens, for instance, will run on that. Run on a tablet. I have a little board here that runs Windows IoT Core. Actually, full graphics acceleration. It runs really well on here. The runtime will run on that. So universal apps will be run on any Windows 10 device, which I think is really powerful. So in a way, that's also cross-platform. But we also do provide support for Xamarin. And I'll talk a little bit about what that is, and then it's what Simran Forms is this session, of course, is about. But the whole point is that the .NET SDK is the same API all across. So the code you write for either of these can generally be reused on the other ones, which I find quite powerful. So Xamarin really grew out of Mono, which was this open source implementation of .NET back in the day that also, for instance, powered Moonlight, which was the open source version of Silverlight that ran on Linux and so on. And it was got picked up by Novell, and then Novell, they dropped it and let everyone go, and those guys then went out and brought it with them and built Xamarin, which then allowed you to compile .NET code into native Android and iOS apps. More platforms come till since. And I think one of the big powers is it's really just, you can think of it as you get to write C# against the Android APIs and C# against the iOS APIs. In a way, really plainly say it, it's not really a .NET API, it's a C# language for those APIs. However, in addition to that, they also took all the mono stuff and compiled, so you get most of the system namespaces like system.io, datetime, and all the stuff you generally write all your business logic against. Those are also compiled and can be used in these platforms, which means a huge amount of your business logic can just be written against standard .NET libraries. And then you can, in addition to that, call straight into all the specific platform APIs and get the full power of that. You can also get to write straight against the individual UI controls of the individual platforms. So you get the full power of the platform and also abstraction at a certain level. And there are certain things that are not shareable, and this is different from Qt, where Qt generally tries to abstract everything. Xamarin tries to abstract almost nothing for all these platform-specific things. So you end up actually writing, even though you get to use C#, you often write, like for Bluetooth, how to connect is very, very specific to that device. But there are libraries out there that tries to abstract that away at a higher level so you can write the same code, just like we're doing with Runtime. And also for UI, there's a thing called Xamarin Forms. This is an abstraction, high-level abstraction of Windows Universal apps, Android, and iOS apps. So you get this abstraction. You can actually use XAML to define your UI. So you get that. If you want to write the app once and you don't want to tailor for the individual platforms, you can use Xamarin Forms for that. Xamarin Forms does even allow you to style for the individual platforms and do certain opt-out. So you can get a little bit of both worlds. And there's lots of libraries on NuGet that gives you some extra abstraction for those things that you don't want to deal with specific platforms. I actually kind of want to mention how we build this, because how we build it also kind of tells the story of how you'll be building your apps. So really, we have this C++ runtime Rex showed like for the whole platform, and we have the same thing. It is the exact same thing that Qt runs on, that Android runs on iOS. It's the exact same code. In fact, it's the same compilation that we're using. We put a little interop on top, so that's how we can talk to .NET between C++, and that's where the whole .NET SDK sits on top. They all build on top of different internal cores of .NET. So there's .NET Framework for WPF, there's .NET Core in Windows Universal, and there's the mono Xamarin runtime that sits inside Xamarin. But really, you don't have to worry too much about that. But in addition, on top, we put these specific UI frameworks, because WPF uses XAML, so does UWP. Android and iOS uses their type of view controls for that. So that at that point, there is some abstraction for each platform that are not necessarily completely the same, but we try as much as possible to make, for instance, the map view control the same on all the platforms, but they inherit from different base classes, so they inherit different behaviors, of course. And if you don't want to deal with that, the common SDK, the native UI, so the blue box is where you write the same code against for all the platforms. This is where all your business logic lives, right? All the stuff down internal, you don't really have to worry about. That's more internal, but it's a good story. But if you don't want to worry about writing specific UI, you also get Xamarin Forms, which supports 3 of the 4 platforms. I actually just heard rumors about a project that does WPF for Xamarin Forms, so maybe we'll take a look at that at some point if that's also important. But this is really how you just view it. There's a big blue box, that's where you write most of your code against, and then there's a little bit for the UI if you do Xamarin Forms, where there might be a slight difference. And I think that's a really cool power. And so your apps on top also can actually stretch across these boxes and for all these platforms for reuse. So let's take a look at what this looks like. Here I have a little app. Oops, let me get that. And my Simran Solutions Pro, you'll see actually at the bottom there's an Office Locator Android, iOS, and UWP. You saw an routing app, indoor routing app. Oh, this is not good. I'm plugged in. That's odd. Huh? That's a little worrying. Oh, there we go. I'm back. I don't know, lose connection. It's loose, it's flashing. Okay, hopefully we'll make it through. Anyway, what were I saying? Here you see the different apps, and that's the one that was shown this morning too, that you showed in iOS. That one's taking this actually a little further. So far it's only iOS, but here where it's all started actually was a cross-platform Xamarin app. Those of you who were last year, we actually showed the beginnings of this. It's gotten a little more full-blown now and real, because we actually released the platform, and we added form support, which wasn't there last year. But really, all the cool stuff is actually, it'll be right up here at the business logic level. This is a shared project, and all this code right here has stuff like how to geocode, there's my main view model, stuff how to provision data to get it offline, do calculations for route. Those are all shared. It's all the business logic for this app. And you'll, for instance, notice in my references here that this is just referenced. This code is just referenced into each project, so they get to reuse it. And then I'll have some specific UI code that basically just binds it up. Here's SAML, as you know it, that actually just binds all this, and it goes from, grabs the map from the VM, and all the different platforms will just grab the same map from the same code that's created the same way and pulled from Portal or so on. So just for good order, here's the app if you haven't seen it. So this is a Windows Universal. I can, for instance, go from my auditorium, and maybe I need to go to the M1 North, the usability lab, for instance. This actually runs all offline, so it does a route calculation. And you'll see it actually gives me 2 alternative routes. This is if it rains, and you go this way. Else this is actually shorter. It never rains around where we live, actually, until recently at least. But then at least in the summer when it's 115 outside, take the dotted line. It's a little longer, but it's not as hot. But it runs all offline. It's actually quite a useful app. And I can run it on my Windows phone. How many here has a Windows small phone? See? Those 2 guys are now happy because they can find their way around our campus. This is an app that's very expensive to build for 2 people. So it would be nice if I could actually reuse this on Android and iOS. And of course, you guessed that. Here I have it running on Android. And that is exactly this project right here. I can do the same thing. And the UI is a little bit different. It's adapted for Android. Let's see if it runs in an emulator, so it'll run a little bit slower. Oh, there we go. But generally the same thing. And here I actually have the markup. For those of you who have done Android development, this will look familiar to you. This is just standard Android markup for the UI. There's no difference here. I messed something up, but normally I get a designer. Right now that's not working. So it's just all XML, but you get a similar thing here. You can actually use the designer in here. Actually, what about iOS? So I can actually click right here and just hit launch, just to show this is not fake. Hopefully it was working. It was acting up a minute ago, but let's see if this works. Let me actually let's set a little breakpoint just to, I'll go into my shared code. Yeah, it was working a minute ago. Oh, it went into standby, no. Hold on. I sat here and kept it alive for a while, and then I forgot, I got distracted. Let's see if that'll connect. It took a little while on this network. Let me try again, start over. Because I think this is super cool, and it's actually a feature they added recently. I don't really like Mac, personal preference, I'm more for Windows. I don't like having to use the operating system very much. And normally when you do iPhone development, you have to do it on a Mac. So Visual Studio for a while has this thing where you can just ship it off to the Mac and it compiles over there and runs over there. And if my thing would actually connect, which it wouldn't earlier, I could actually, I was really happy it was finally working a minute ago. This network hasn't been very kind to this. But what it really does, it does a remote desktop over to your Mac, or the equivalent of remote desktop, and it actually shows the iPhone simulator on your Windows machine. So you can just take the Mac, put it far away, right? Just keep it on, and then you can sit here on Visual Studio, debug, step into, inspect, do all the stuff you normally do in Visual Studio without ever having to look at that god-awful thing again after you set all the tools in. I don't know, some people like Mac, and they have their good sides. But you can also, if you do like Mac, then you can actually do Xamarin Develop for Android and iOS on there as well.
It did work.
You saw it work, yeah. It's working down at the island right now. If you go down and look at the same app is running. Why don't we just switch to we'll do Android instead. This is real. I guarantee. Why don't we set a, let's see, where do we geocode? Let's just do it right here. And oh, and another thing you get by running the iPhone simulator on your Windows PC remotely like this is touch is working, because Windows has touch screens. This thing is, I just get fingers on there, nothing happens. But it's actually really cool, you can do that. Boom, boom, boom. I'm bummed. It was running, it was all up and going. It's the Mac's fault. So here we're deploying. I'm actually using the Visual Studio Simulator. So Microsoft made an emulator for Android, which is kind of crazy. And it runs better than the ones that Google is making because it's built on Hyper-V. So it actually runs straight against the hardware versus everything is emulated, which is really, really powerful and a really good emulator. There's all pros and cons on both, but that's personally my preference. You can, of course, also connect to a device. I had hoped to see all apps side by side here, Windows, Android, iPhone, but it looks like I'm not that lucky. App's not launching. You can even see my output window down here going crazy. No smokes and mirrors. Q. Oh, something happened. I pressed Q, and let's see. I can see right here. Can you see it? It says Q1. And I can step through. I got my beautiful async await. I'm not sure what happened right there. What did I end up over there? There we go. Here's my list of suggestions. I can actually step in through. With the tool I know and love, so if I'm a Windows developer, I've done C# my whole life. I don't really have to learn so much new, which is really neat. I mentioned also Xamarin Forms. So I have 3 different UIs over here that I have to build, one for each, which gives me the power of really adapting to the platform. However, it's also a lot of work. So Xamarin Forms here is actually, I have 4 projects now, but these first 3 projects are really, there's nothing besides what the project created, and all they do is launch the shared view. That's really the only thing that's different about them. And the shared view is this campus map page. It is XAML, and we fully support forms. So we have a special forms control that is really just, you can see the namespace here, grabs it from the runtime forms and creates a map. I'm not sure why I'm getting squiggles right now. But it's the same thing, and you see I'm binding to the map that's from the same view model that I was reusing. So there's a lot of reuse of code here, a lot of reusing of skills, which I think is super, super powerful. And that way I don't have to create it. All this code for this app is actually online on our demos repo, so you guys can take a look at that. Yes, we're in time. Okay, so pros and cons. Xamarin is free, which is actually really cool. It's open source even. All the source codes are available. You can take Xamarin Forms and fork it and change it if you want to. Just note that it comes with Visual Studio, and Visual Studio is probably not free for most of you. There is a community edition, but for most enterprises that is not. Is that correct? That's not. You can't use that. But at least you can use it in your spare time. If you're fancy that. But I love that I can sit in Visual Studio all day. I don't have to switch between IDEs for different platforms. I don't have to switch between operating systems to deploy and run on different platforms. It's really, really neat. And Xamarin has a habit of the day that iOS or Android releases a new version, they have updated their APIs to expose all new APIs every single time, day one, which is really, really impressive. There's no waiting for it. Even in the betas, they generally release updated SDKs for those betas, so you can start taking advantage of all the new stuff that the phones come out with, which is a huge pro, I think. There is this thing that you do write some platform-specific code, not always fully abstracted. If you go and look at the sample, you sometimes see that I deal with file paths quite different, how I unzip files, or how I deal with. In this case, you don't have to worry about GPS things because we have a GPS out of the box for you, so we wrote a bunch of code for that. But just as an example, we have very different implementations for how to handle GPS on all 3 devices. We abstract that for you. The tooling sometimes is a little buggy. However, this morning, Visual Studio 2017 launched, and there's a huge amount of new features with Xamarin, especially Xamarin Forms has huge designer support, much better IntelliSense. I'm all excited. I didn't dare install it fully this morning before my demo. Maybe on Thursday when we have another session, I might be running on it. But there should be some big improvement there, so that I'm very excited about. And then, I don't know if this is a con, but you have a Mac to do iOS. You have to buy a second machine for that. Or you just do everything on Mac. You can use Visual Studio from Mac, which I think they just launched the fourth preview today, or Xamarin Studio, which seems to be replaced slowly by Visual Studio from Mac. So you can all do it there, then you just can't do Windows apps. So grab that. And then there's a really cool offer this morning too. They said, if you go today, right now, before March 14th, and just download Visual Studio 2017, you get a 6-day offer, free access to the Xamarin University. I mean, it's a bunch of training and stuff like that is really, really good, like hours of training of Xamarin University. So if you're getting started with Xamarin University, just go and hit the download button, and this thing just pops up. Like, you see, I just finished downloading 1 megabyte, and then I got a free offer. Definitely take advantage of that if you get started with Xamarin. There's lots of really, really great content there. It's actually pretty expensive, I think, to get access to Xamarin University. So that's a good boost to give you 60 days to get started on it. So that was, I think, that.
Okay, good stuff. Great, thanks, Morten.
Unless you just want that one.
Oh, you have that? Okay, that's all we got. Good deal. Yeah, so Xamarin University, I have to admit, having used it myself, it's probably one of the best, most well-documented, I guess, experiences I've encountered. It's actually somewhat expensive, so this is a pretty good offer if you're looking to get started. Have to admit, I think the original perspective title for this was Cage Match, Fight to the Death. 3 SDKs enter, 1 SDK leaves. Cross-platform. I jest. I'm just joking.
Oh yeah, the reason I have Java installed is because of the Android tools. They require me to do it.
So some opinions, obviously, on the different technologies, which is great. It's great to hear. It's good, well-spirited. A common question that comes up is, can we flip over to the?
Oh, sorry, I don't know why I just did there. I forgot it was on.
Oh, no worries. Just have one last slide here, but before we dive into that slide. A common question that comes up, we hear at the island or maybe in individual meetings, maybe with a little wink, wink, nudge, nudge, can you tell me what the best Runtime SDK is, right? There's not really a best Runtime SDK, right? They're all of equal high quality, right? So we build it on the common core, so they all share the same functionality. It really comes down to what I mentioned at the very beginning, which is the best tool for the job, right? And it depends on your user community, what you need to target, and it depends on your developer skills or your development team's development skills, right? So all runtimes, same quality, right? Best in class, but you need to really evaluate and determine what would be best and most productive for your experience and for your users. To help, so to take it a little bit beyond what we've presented here in the cross-platform section, in about a half an hour, we have a building Xamarin apps with ArcGIS Runtime SDK for .NET. This focuses just on the Xamarin tooling and capabilities within the Runtime SDK for .NET. It's in a demo theater across the way here over in Oasis. Tomorrow, we have 2 tech sessions. Runtime SDK for Java, building apps at 10:30 in the morning, and then the Runtime SDK for Qt, building apps at 2:30 in the afternoon. So we're going to go into more detail there. We'll get some more information from our resident experts in the technologies at hand, which is fantastic. And then we'll finish on Thursday with an ArcGIS Runtime SDK for .NET building apps, which will give you a comprehensive view of building applications with the Runtime SDK for .NET using the .NET platform. Now with that, actually one last thing, just mentioned over on the side here is, if you're looking at what we're doing in the future, what we plan to support in the future, we have a road ahead session coming up on Thursday, and then if you have some questions that you'd like to ask the development team, the Runtime development team, we'll be on hand and at your mercy on Friday morning at 10 o'clock. If you've been to these before, they're actually quite interesting to attend. We don't record this, so you'll need to attend. We also don't record the road ahead, so you need to attend to actually see that too. So those are 2 special sessions that if you're here physically attending the Dev Summit, you get to take advantage of. Just want to mention those. So with that, I'd like to, I think the next slide is questions, is that right? Yep, there we go, good stuff. So with that, I'd like to open up for questions, and let's see what we can have. Yep, right back here.
My question is, like, what's the reason behind Esri choose Qt for apps?
That's a great question. So kind of leads into my, what's the best SDK, right, question that we often get. And so when App Studio was built, they needed to be able to target every platform. And they needed a mature Runtime SDK that was available at the time. The only Runtime SDK that supported every platform, and it was available, was the Runtime SDK for Qt. They needed to be able to target iOS, Android, Windows, and Linux, and Mac. And they can do that, and Qt can do that. And so they had to ramp up their development team on Qt and the development platform to be able to build out a solution that could target every platform, right? That was the best tool for that job, right? Yes, Drew.
Have you considered looking at React Native for cross-platform development as a runtime SDK?
Are you guys familiar with any research in that area? At this stage, no, not that I'm aware of, actually, but our ears are always open, actually, to newer technologies, new technologies, or existing technologies that might be conducive towards a native development experience. Yep. Yes?
I know they're all really great to make. I'm sure they're fantastic. The only thing I'm concerned about is the lifetime of those, so like the support on all those different runtimes. Like, I mean, it's possible that maybe 10 years or something drop a queue or something like that doesn't happen. So I just didn't know if there's anything in the future dropping some support on either ports or whatnot.
So there's always potential. Actually, I mean, we're building on a platform that we don't own, actually, and so the vendors on which we're building and the platforms on which we're building can choose to go different directions or can choose to end of life some of those technologies or targets. And so it's possible that what we're building on actually changes. But obviously we're working with a development experience, whether that's an IDE or a developer platform or targeting an operating system. And so we're building on tooling that's available as part of the industry, right? So we're really matching what the industry provides. And so if the industry moves towards, well, some flavor of Linux is not something that we want to be able to use, then we probably won't support that. Or let's say for some reason, the Mac OS dies at some point and people don't want to use a MacBook anymore, or they don't like the Mac operating system, then maybe that's not a runtime SDK we need to support, right? So those are possibilities. Or something else begins. There's a new technology that we need to pay attention to, right? That's part of being somewhat nimble and flexible to being aware of what the industry is using and what the community, the developer community, is looking to target at this point. So sometimes we don't have a control over that, right? But we do try and match it. Now I do have to admit our product life cycles for our runtimes tend to match. That might be good for, let's say, mobile devices. Actually, mobile platforms like iOS, which tends to be quite aggressive, might not be quite so good as, let's say, for Windows desktop platforms, which tend to be a bit more long in the tooth. But we try and find a happy medium in there somewhere so that we can actually support our product for a duration that's reasonable at this point. Any other questions, guys? Yes, Corey.
How much is Esri looking at the teams developing the JavaScript technology and the teams developing the runtime technology? How much are you guys coordinating about disconnected JavaScript?
Right. So right now, with the new releases, the latest major releases of Runtime 100.x and JavaScript 4.x, what we find is a similar API architecture, right? So we want a similar developer experience. So you'll see similar workflow designs. You'll see similar nomenclature associated with the APIs. Ideally, we have very similar functionality with respect to connected workflows, which is what the ArcGIS Runtime SDK for the ArcGIS API for JavaScript is designed to support. There is research, actually, at this stage in looking at what we can do to provide a native experience for JavaScript developers, right? And whether that looks at Cordova or another technology, we'd like to look into that and see what's available. Inevitably, though, it's still driven by runtime, right? So even if we do provide some sort of a JavaScript experience for application development that takes advantage of offline workflows, runtime will still underlie that technology at this stage, right? But it's still, obviously, it's an open question. It's something that we are actively researching and looking into at this point. We don't have any announcements at this stage, but it's obviously that hybrid approach to being able to build a native application, but leveraging web technologies is something we want to be able to support. Any other questions? Great stuff. The last slide here, I think, actually might be just a reminder, I believe. Oh, no, I'm sorry, that's the There we go, good stuff. So if you guys get the chance, in your conference app, you can go out and submit some feedback. We'd love to hear feedback from you. Again, thank you for attending. We'll see you at the conference. Thanks. Thank you.